Hello and welcome to a Unity tutorial on how to make your user interfaces more juicy. So today we're going to be covering how to make elements of your menus or heads-up display kind of slide into place and scale up as they're doing it. Like you can see here, everything is kind of sliding in. This is an example from a game that I'm working on currently, and all of the HUD kind of pops in, the pause menu slides into place, so everything just looks really nice and juicy. So what we're going to do is, instead of using, like some people might, a animation system using the animator and animation components in Unity, we're actually going to be using a script for this. So this way, instead of having to make a custom animation for each individual element, you can just make one script, pop it on the object that you want to use it on, and then change around a few parameters. It's very modular. You can use it in many different ways. So we're going to be covering how to make one of these. And I'm going to go ahead and open up a new Unity project and show you from scratch how this works. All right, this is a brand new Unity project. I went ahead and did a little bit of setting up off camera, but basically all I did was I set the background color of the camera, and I added a canvas with a title, some buttons, and I went ahead and added the Roboto font and just used a custom button image. It's just a rectangle instead of the kind of weird looking default button from Unity. So to start off here, we're going to add a new script, and we're going to go ahead and call that animated entry. And we're going to open that up in Visual Studio. All right, we can start by removing the update function. We will not be needing that. And we can remove this comment. And the first thing we're going to want to do is add a public vector3, and we're going to call this start scale. We're also going to need a public vector3 called start position, or start pose is fine. And then the other thing we're going to need for each of these is a public, it's called animation curve. There it is. And we're going to call that scale curve. And we're just going to make another one of those, but we're going to call this one position curve. And we'll see how these work in just a second. But first what I'm going to do is I'm going to make this a little bit tidy, because we're going to be adding this into a lot of different game objects in our scenes. So it'd be easier if we have some headers going on here, just so it makes it easier for us to find stuff when we're going through different objects. So I'm going to do, this part's completely unnecessary, but I'm just going to add a space attribute here of 10, and then, because I'll have stuff above this as well, and then I'm going to do a header attribute. Whoops, wrong kind of brackets. Header attribute, and I'm going to put the header of scale here. I'm just going to copy this and put that down between my scales and positions. And I'm going to have that above there. So that way when I go back into Unity, you'll see it has these nice little headers here and some spacing. So that way we can edit things properly. So also you can see here the animation curves in the inspector, since we made them public, show this little box here. So if you haven't used an animation curve in Unity before, basically what we're going to do is we're going to have points between 0, 0 and 1, 1 right there that we can sample from. And they can actually go outside of this box as well. But the idea here is that instead of having to make some complicated equation to have our variables output the right amount, we're just going to use an animation curve instead. So I'm going to go ahead and make the animation curve right now, or in this window already. So mine's going to look And you can really do this. This is the part that really makes it unique and makes it look however you want. I'm going to use the default here to start with. I'm going to go ahead and add a key here. And so this just defaults does a smooth graph from 0, 0 to 1, 1. And we want it to end at 1, 1 and start at 0, 0. And I'm going to pull this point a little bit above there. So it's going to shoot past a little bit. And add another key here. So it's going to come like back down a little bit. So it's going to basically overshoot its position. And then it's going to come back a little bit like rubber band. And then it's going to eventually lead back into the position that it was supposed to be in. So that's one of the curves. I'm going to go ahead and do the exact same thing over in my position curve. All right, so going back into Visual Studio, we're going to need a couple more variables that are actually going to be private here. So we're going to need a private vector3. We're going to call this one end scale. Can't type today. And then we're also going to need another vector3 called end position. And then we're just going to set these as the whatever position it is when it first starts. Now we're actually going to do this in a separate method than the start method, just because depending on how we're using this, we might want to call it in a couple of different places in either awake or start. If you're using, for example, a pause menu where you're going to be having them become awake and then immediately moving them, you might want to do it in awake. So we're going to have it set up a little bit weird here, but for starters, we're just going to make it in a different method, and we'll just call it from start. So we'll do setup variables, I guess we'll call it. And so here, all we want to do is we're actually going to be basing this off of the local position of the object, since all of these will be parented to a canvas. We'll use their position relative to the canvas to keep track of where it is. So we're going to set end scale to transform dot local scale, and then we're going to set end position to transform dot local position, and we're going to call that right here. Set up variables. There we go. So now we're going to go ahead and make a coroutine. A coroutine is probably the best way to do this instead of, I don't know, repeatedly calling stuff through the update method. A coroutine is just going to make this a lot easier to do. So we're going to do iEnumerator. Let's call this animate. I think the public thing we're going to call is going to be called animate. So let's just do animation or something like that. All right, and obviously this is going to go right underlined because it does not return a value right now. We're going to have that sorted out in a second here. So the first thing we want to do for our enumerator is we're going to make sure that it's in the right position when it starts. So that way, if it for some reason gets called more than once in a row, it'll just warp back to where it's supposed to start from the animation. So we're going to do transform dot local position equals start position, and transform dot local scale equals start scale. And then we're going to go ahead and set up a few variables that we're going to be using while this coroutine goes through. So we're going to make a float called time, and this is just going to represent the amount of time we have progressed through the animation. We're going to have a float called percent, and this is going to be the percent through the animation that we are currently at. And then let's see, we're going to make a float, float called last time. Now, if you do your animations in all real time where this time scale is set to 1 or anything but 0, you won't need to, you can do this part a little bit differently. I'm going to do it this way because if you use it in a pause menu like I do in part of my game that I'm working on, you'll want to use real time since startup instead of using the actual time variables. Because if you set time scale to 0 like you would for a pause menu, you won't be able to sample time in the same way. So I'm going to use time.realtime since startup to find out what the actual time is regardless of time scale. And then we'll be using that again to sample and see how much time has passed instead of using time.delta time like you normally would. So now I'm going to make a loop. I'm going to say do while, and we are going to check against the percentage variable, and we'll get into incrementing that in a little bit. So as while percent is less than 1, we're going to do what's inside these brackets here. So the first thing we're going to do is we're going to add to the time so we know how much time has passed since the last time we've called this. So we're going to find what the time is right now. So we're going to do time.realtime since startup, and we're going to subtract that from whatever the last time is. So that way that'll find what would normally be called as the time.delta time. This is finding that even if we have time scale as 0, like if we're in a pause menu. And then we're going to set the last time so that doesn't get messed up. Time, real time since startup, there we go. And then we're going to change our percent value. So this value is going to be telling us how far through the animation we are. So actually, I believe there's one variable we forgot to do before writing this. So let's go ahead and put that up here. We're going to put that at the top here. And we're going to call this, we're just going to be a float. And this is going to be, I'm going to call this effect time. It's going to be how long it takes for the effect. And I'm going to default that to 1, just so we have something to work with. But this is going to be a public float, so that we can edit it in the inspector for each object. So percent is going to equal mathf dot clamp 01. So what this does is this will take whatever value you put into it and make sure it's either 1, 0, or somewhere in between 1 and 0. All right, so what we're going to do for this is we're going to find the percentage through the effect it is. So this is going to be our time. And we're going to divide that by time of effect. Oh, effect time, I mean. We're going to make a new vector 3. We're going to call this temp scale. And we're going to make that we're going to use vector3.lerp. So this will linearly interpolate between two values based on the percentage value that we're going to plug in here. So for this, we're going to use start scale and end scale. So we're going to do, I believe they call it scale curve, and then we're going to do dot evaluate. And that's going to be evaluate at the percent. So that way, if the percentage is 0, it's going to give you the y value at the beginning of the curve. If it's 1, it'll give you at the end. And anywhere in between, it'll give you that value that it is. And we are actually going to, I'm going to go ahead and write it out. So we're going to do another vector 3. This is going to be called temp position. This is going to be another vector 3.lerp. That's going to be start position, end position, and then it's going to be the position curve dot evaluate at percent. Make sure you close that off of a semicolon. And actually, I just realized instead of using lerp, we should be using lerp unclamped. If you do lerp It will not accept values that are over 1 or 0, but the whole point of this is to, of course, make it so that we can do this little rubber banding where it goes past a little bit. So we'll want to do unclamped there. So after we've captured those values, we're just going to go ahead and apply them to the actual transform of our object. So let's do transform.localScale equals temp scale, and transform.localPosition equals temp position. And then after all this, we're going to let it, we're going to call yield return null. And then that will go through and step through the whole thing. And then once the time is equal to or greater than the effect time, this percent value will equal 1, which will bring us out of the loop. And then after that, just to make sure, in case there's some kind of weird, like the frame rate's really low or something and it misses giving you the correct end position, we're going to go ahead and do transform.localScale equals end scale, and transform.localPosition equals end position. So that way, at the end of it, we'll just snap it to where it's supposed to be, just in case it's slightly off. All right, so after that, let's see, I believe this is actually ready to be tested. So let's hop back into Unity. And let's give this some value so it can actually work with it. 350. Oop. 350. And it's going to start off with 0, 0, 0 for scale. And when we press play, it should... it does nothing because I did not call the coroutine. So in start, we'll want to go ahead and put start coroutine, and then the name of it is animation. So we'll put an animation. And that should do it. There we go. So we have a nice little animation coming in there. Now there are a few more things we want to do to this, but this is definitely a good start. So you can see it's coming in from the top, and it's also scaling in, and we can have it do all kinds of different things by just manipulating these variables. But we do want to have a few more things going on here. So let's go ahead and add in some more variables to get a little bit more out of what we can do with this script. So the first thing I'm going to do is I'm going to add an option for delay. So we're going to put public float, and we're just going to call this delay. And what this is going to do, we're going to default that to 0 because most of the time you're not going to want a delay. So what this is going to do is it's just going to hold up the animation and wait right here after it's set it to be where it's supposed to start at. We're just going to have it hold there until the delay is over. So that way you can more easily control what order things pop into the scene at, which is going to become a lot more apparent when you have multiple things coming in. So we're going to do yield return we're going to do a new wait for seconds. Oops. Wait for seconds. Real time to keep consistent with the rest of the real time stuff we're doing here. And we're going to put that in as delay. So whatever that is, we're just going to wait that long, and then we're going to go and do the rest of this here. So that way, it'll already start, it'll set it up, and then it'll wait, and then it'll start moving it after the delay is over. So let's check to make sure that's working. So if we go in here, first we'll see the delay will pop up, and we'll go ahead and set the delay to, I don't know, 5 seconds, just for testing purposes. And that makes it very obvious that that is working. So there we go. We're going to go ahead and set that back to 0 on this one. So I think the title is probably the first thing we'll want to have pop in. But just to keep this nice and tidy, we're going to go ahead and do another spacer and header attribute. I'm just going to go ahead and copy this over so you don't have to watch me doing that again. We're going to name this timing. And there's only, I believe there's only 2 more variables we want to put in here as far as how we want to control this. So these are going to be the bools. I'll go ahead and just put the header in right away. So I want to be able to control 2 different things with this. So I want to be able to control whether it's animating at the start. So I'll do bool animate on start. I'm going to set that to false to begin with. Oops. But on all of these ones, we're actually going to go ahead and flip that to true. And then we're also going to do another bool. And this one's going to be called offset. Whoops, offset. And that one's also going to be set to false to be, by default. Technically, you don't have to write equals false whenever you're doing a bool. That's the what it's automatically set to if you don't put in anything. But I'm going to go ahead and write that anyways. So to do this, we're going to want to do a couple things here. So first of all, under start, we're going to go ahead and put if animate on start. Then we want to do this stuff here. All right. And then we're also going to make an awake method. Now, this is not going to be apparent as to why we're doing it in this example, but for the UI that I'm doing in my own game, I needed to do this just so that it would work for pause menus, which is the whole point of doing all the real-time seconds there. So this way, if, for example, you set a bunch of objects active at once and then immediately tell them to animate, it'll set things properly. So for this, I'm just going to do, if it's on awake and it's not set to start animate on start, I'm going to set up the variables here just so that they're set up correctly, because it does all kinds of weird things with the animation if you do that. All right, so the next thing to do is we're going to want to implement this offset variable. So we're going to go into the setup variables area, and we're going to say if offset. And then here, what we want to do is we want offset to mean that if offset is checked, instead of it taking this start position variable as its actual local position to start from, we want it to use that as the offset from its original local position. So that way, if you don't know what the screen size is going to be and you're scaling the canvas to that, it may mess with how things work here. Now, if you have them all centered like I do, it probably won't be a problem. But if you start doing stuff that's like corner centered or top center or something like that, it can be a bit of an issue. So this way, it'll just take whatever value but here, and we're going to have that added to the position that it's at. So what we do for that is we do start position plus equals end position. And that's all you have to do there. Now the reason it's actually pretty important to have these if statements for the animate on start is because if you don't have this here, it's actually going to do that twice. So you'll end up with it offset like way to the side, which is not what you want. So there's that. Okay, I believe that's just about everything we want. So if we save this and head back into Unity, what I'm going to do is it can be a little time consuming to make these animation curves. So I'm going to go ahead and copy this component. Now, I mean, you can do custom curves for everything that you want. I'm going to go ahead and make them the same on all of these just to make it easier for the tutorial. And so those will all have the same value. So we're going to want to play around with these values a little bit. So let's make the title will come in right away, and it'll just come down like that. Let's have the button come up. So this is going to be, did I not? I didn't make that a public bool. I did not make these public bools. I want to do that. Yeah, I forgot to make the bools public so that they'll show up in the inspector. All right, so I want these all to animate on start, actually. So the play button, that one's going to come in from, I don't know, let's see. Let's go from down. So it'll be like about negative 350. Let's have this one come in from the side, so the Y is going to be 0. And let's make the X about negative 500. And for this one, we're going to do the exact opposite, so we're going to come in from the right. And we're actually going to make both of these offsets, so we don't have to worry about the Y value. And we're going to make the play button delay slightly. I'm going to make this about 0.2. And let's make these two delay 0.5. And let's see how that looks. So as you can see there, that's a lot more animated, and it's a lot better than just having it stuck up on the screen there. And you can play around with these however much you want, just to make the effect look as good as you want. You can mess around with the curves on individual objects if you want. You can make things, for example, have a different start scale. Like if you put the X scale to 1, it'll only scale to Y, so the title will kind of like go in a little bit differently there. So you can do anything like that to mess around with it. All right, that is all I have for you today in this video. If you stuck around to the end, thank you very much. Go ahead and smash that like button down below, or leave a comment if you have any questions, anything you'd like to say. Just let me know down below there. If you like this video and you want to see more like it, go ahead and hit that subscribe button. Have a great day.